Hello everyone, I am Masood Ibn Abdul Wahid. Today we are going to start the project series video. So what the series of videos will be consisting of is developing a small robotic car which can be controlled and which can do many operations, but all the abilities of the robotic car cannot be discussed in one single video. So actually I have made this video to be series of videos. So let us start with series number 1. So in this video what we are going to discuss is an Android phone controlled robotic car. We are going to assemble a small car. So this car we are going to assemble and we are going to control it through our Android mobile phone. So using Arduino and Bluetooth module. And for controlling this we are going to develop our own customized Android app using MIT App Inventor. So let us begin with the items required for doing this. We need the small toy car and it is shown to you here, and we need a Android mobile phone to control this vehicle, and in between these two we are in need of the main microcontroller, which is our Arduino. So Arduino is having many variants in that, so we are going to use Arduino Mega. So you may have a doubt that why can't we use Arduino Uno. So if you use Arduino Uno, we need to control the motor using a motor shield. So if you embed the motor control shield on the Arduino Uno, all the ports will be engaged. So there will be no ports available to connect your Bluetooth module, which is the mode of communication, mode of connectivity between the mobile phone and the Arduino microcontroller. So that only we cannot use Arduino Uno for this category of car control. So that we are going for Arduino Mega board, which is having more ports compared to Arduino Uno. And to control the motor, we are in need of the motor shield, motor driver shield, which is numbered as L293D. To power the motor, to power the Arduino board, let us use a 9-volt battery with a snap connector. So these are the main items required. Of course, some other tools we will be in need of, which we will discuss when we assemble and when we do the circuit diagrams connection. First of all, if you take or if you get the motor chassis and if you open the packet, you can see all these parts as discrete. So you have to assemble like this, what it is shown to you as assembled view. After assembling the robotic car, so we will go into the circuit diagram. First of all, we have to connect the Bluetooth module with the Arduino Mega board. So for that, of course, every one of you might know, the Bluetooth module will be having 4 terminals. The Bluetooth module will be having 4 terminals, as you can see here, marked here: VCC, ground, TX, RX. VCC is our plus 5 volt and ground is 0, and TX means transmission pin and RX means receiving pin. Okay, so according to this view, front view, these are the pin configurations. And the 5 volt pin will be connected with the Arduino 5 volt, and the ground pin of the Bluetooth module will be connected to the ground pin of the Arduino Mega board, and the TX pin will be connected to the RX1 pin of the Arduino Mega, and the RX pin of the module will be connected to the TX1 pin of the Arduino Mega. So you have to connect it in vice versa. TX should be connected in RX and RX should be connected in TX. So again I am mentioning, so this TX RX should not be connected in the pin number 0 and 1, because when you connect the motor shield, motor driver shield, this pin will become engaged by the motor driver shield. Okay, so you should not connect it here, you have to connect it here. And there are 2 motors in the motor chassis. So those 2 motors we will be using to direct the motor, maybe in the front side or in the back side. You can use one motor if you decided that you are going to control the robotic car only in forward direction or reverse direction. But once if you go into the thought that you want to control the motor both forward, reverse and also right and left turns, so you have to use 2 motors. Because with one motor you cannot control the motor's direction from right or left. Only front and back is possible. In the front side of the motor you can have this caster wheel. No need to connect a drive wheel here. You can have this caster wheel in the front side, so that it will decide its rotation depending upon the drive wheel's rotation. or if you intend, you can have two caster wheels in the both corners, or if you decide, you can have two free wheels without any motor, same like this wheels you can have in the front side without any drive motors, which can rotate freely with the direction decided by the drive wheels. And of course, to power up all these things, we are going to use this battery, 9-volt battery with a snap connector. The snap connector's positive pin will be connected here, and the snap connector's ground pin will be connected to the ground pin of the motor driver shield. Let us take all these components and do the physical connection according to the circuit diagram.
As I have said to you, so this is what the assembled view of the two motor drive car chassis with the caster wheel. So here are the two leads of motor 1 and the two leads of motor 2, and one extra thing what I have did is I have attached a switch for switching on and switching off the circuitry. This is the snap connector which I mentioned, and through the switch the red wire is going to the VCC point and the black wire will directly join in the ground point. So this is the Arduino Mega board. This is the motor driver shield. This driver shield is capable of controlling 4 motors. So you can have any combinations. You can control DC motors, stepper motors, servo motors. All these categories you can control. These two are the external power supply points. And if you need extra grounds or if you need extra ground positive wires, you can solder it here as I have soldered here. This is the Bluetooth module, which is the connectivity between the Arduino board and our Android phone. So these 4 terminals will be connected to the Arduino board using male to female connector and some female to female connectors. This is the 9-volt battery, which is the power supply for the entire robotic car. So now we will connect the circuitry. First of all, take the Arduino Mega board and place the driver shield over the Arduino Mega board like this. Press it firm. Okay. So this is where I set. So this is the pin number 0 and 1, which is the RX and TX. So it will be engaged with the Arduino driver board. So this is why we cannot use Arduino Uno here, for which we have used Mega, which will have extra TX and RX pins for serial communication.
So take the Bluetooth module, connect the connectors. So here yellow wire is the VCC, positive 5 volt. So connect it with positive 5 volt line and connect the ground with ground line. And as you can see, green is the TX. So connect the green in the RX point of the Arduino Mega. So the last connection, the blue color wire connector is the RX pin of Bluetooth module. So connect it with TX pin of Arduino Mega. And after this, take the assembled car, place it over the car. Now you can place the Bluetooth module somewhere. All the required connections has been made. So this is the snap connector. Here you have to connect the battery. So if you switch on, you can see the power on indicator LED for driver board, and this is the power on indicator for the Mega board. Power on indicator LED for Bluetooth is working. Now we will go into the coding section. So far we have finished the connections according to the circuit diagram. Now we will go into the workflow or working methodology. So once you switch on the power, the Bluetooth module will search for any client is present around the module. So if there is no client, it will again and again search. And if you connect the Android mobile phone with the Bluetooth module through Bluetooth connection, it will go into the checkbox to read what is the received character. So here we have classified the characters into 4 categories: F, B, R, L, which is the first words of the 4 direction: front direction, backwards, right direction and left direction. If we send a character F from the mobile phone, it will receive the character F and it will give the positive voltages for both the motors M1 and M2, so that both the motors will run in forward direction to take the chases or to take the robotic car in the front side, in the front way. Likewise, if the character received is B, both the motors will be electrified by reversed voltage. So both the motors will be driven in reverse direction so that the car will be taken backwards. If it is If the received character is R, then it means the car to be turned in the right direction. For that, the motor 1 will be driven in forward direction and motor 2 will be driven in reverse direction. Or otherwise, what you can do is, you can just drive the motor 1 forward. You can keep the motor 2 to be without any electricity, so that it will be stationary, and because of the rotation of motor 1, the car will be turned into right side. So what is the difference between these two is, if you electrify the motors in opposite polarities, it will have a quick turn. To turn the motor slowly, what you can do is, you can make the voltage of one motor to be 0 and you can give the voltage for only one motor. So this is how you can create some changes between in the turning time period. So likewise, same for the left side also. So if you give a command, it will be received and the operation will be going on accordingly, and it will be continuing until you send the next command. And this methodology to be written as a code in the Arduino IDE. So you can see a link in the description how to add the Adafruit motor shield library into the Arduino IDE. You can download the zip file and you can attach it into the Arduino IDE so that you can use this header file. So whatever I explained in the flow chart, control flow, workflow, so it is written to be in the coding. So this two codes is for including the two motors in the port 1 and port 2, and this is the setup to begin the serial port communication and to set the speed of the motor 1 and motor 2. And inside the loop, first of all, we are checking whether any Bluetooth client is available or not. If it is available, it will go into the loop and it will start reading the characters. And by using a switch case statement, we have classified the operation of the motors according to the character received. The command release here means it will stop the motor. You can use the code and you can directly put it in the Arduino IDE and you can start using the code. So now the last part, but the important part, is developing the Android app for this purpose. So for which we are stepping into the MAT app inventor. So of course, just now we finished what we need to do in the Arduino IDE, and next part is we have to develop the graphical user interface, for which I am using MAT app inventor. So now this is the graphical user interface, as you can see here, and now I am going to show it how it was developed in general. Let us develop this app from the scratch up to the last step in a different video, because it will make the length of the video to be more. If what I have planned is, let us go into the respective web page. I will show you what are the important things and how it is developed in short. So in detail for the development of this app, I will explain you in the next video, which is a dedicated video for developing this app from the scratch up to the last step. So to get into the MAT app inventor page, you can go into the browser, and for your information, so for using the MAT app inventor, you need a Gmail account. Then only you can able to log in into the MAT app inventor page and you can start creating your apps. So go to the Google page, type MAT app inventor. This is the corresponding web link. So by clicking this, it will take you to the login page where you have to enter your Gmail account and the password, and by entering and by clicking continue with MAT app inventor, it will take you to this page where you have to click create apps. By clicking this create apps, you will be directed into this page. So you will be ending up here. So just for information, these many apps I have created. The app which I want to show to you is this one. So about the app inventor introduction and about how to develop this app from the scratch up to the last, I will explain it in a new video for you. Let us finish this video by seeing just alone this app design and the blocks used for that. So this is what the designer page of the app which I have created. To finish the app in this look and feel, I have used these many components, and for each components there are some purpose which is programmed using this block commanding. So once you finish everything in the designer part and the block programming part, you have to go to the build and you have to download the APK file. So when you click the APK file, so it will start progressing, it will start preparing, and it will give you the developed app in two ways. One is through a link and another one is through a QR code. So in your Android mobile phone, you can download the MIT app companion. By opening the app companion, scan this QR code and you can download this into your mobile phone and get it installed. After installation, now it is all set ready. You can control your robotic car, which we are going to see now. Now we are going to switch on the main switch of the robotic car. After switching on, you can see the power on indicator of the driver board is switched on and power on indicator of the mega board is switched on, and you can also see the Bluetooth power indicator also switched on. You can see the frequency of the switching on and switching off. It is quick. It indicates the power is coming but no Bluetooth client is connected. So now we will go into the developed Android app. So in the app, you can see one button called as tap to scan the Bluetooth devices. Tap it and you can see all the available Bluetooth clients. Among this is the HC06 is the Bluetooth device which we are using. So you can see the status, one Bluetooth device connected. So it means the Bluetooth module which we are using and our Android mobile phone is connected via Bluetooth connectivity. So now you can tap the start button to start commanding the robotic car. Now by pressing the corresponding button, you can see the robotic car will be driven on that particular direction. So just for information, so the side in which we have connected the caster wheel is the front side and the side in which we have connected the two drive motors is the back side. We will get a voice feedback from the app. Let us make the robotic car go in the front direction.
Rover moving forward. Rover stopped. Rover coming back. Rover stopped. Rover turning left. Rover stopped. Rover turning right. Rover moving forward.
Also, as I mentioned, you can see tap the mic to do voice commanding. So you have to tap this and you can send the voices to command the robotic car. Right. Left. Front. And I have mentioned you about the accelerometer sensor. Just shake the mobile phone.
Vibration observed.
You can hear the voice feedback as vibration observed. At the same time, the robotic car will be stopped.
Rover coming back. Rover stopped. Rover moving forward. Vibration observed. Rover coming back. Rover turning left. Rover stopped. Rover moving forward. Rover stopped. Rover coming back. Vibration observed.
Hope you enjoyed the video. As I said, maybe in the next video, we will see the step-by-step procedures to develop the MIT app right from the scratch until the final step. Let us meet in the next video. Until then, I am Masood Ibn Abdul Wahid signing off.